Okay, good evening once again. Today's lesson is going to be a continuation of what we did previously, and this is two of two, okay? And that is axis and basis. The first one, the first section, we did it previously. We are ending it today. Let me also quickly add and remind you, I think I said it previously, that this topic will be repeated in grade 12, so you still have to take it seriously. You can't just run away from it because you are finishing grade 11. You still need it in grade 12. Okay, so we're going to talk about the pH and pH scale. Now, uh, okay, so why do we talk about pH? Why do we talk about the pH scale? The reason is simply this: the concentration of hydronium ions and let me change the color of this thing so that I get a better. Okay, so the concentration of hydronium ions and hydroxide ions, I think I should put ions here, ions are low. So it makes sense to find what we call the negative logarithm of these concentrations. And when you do that, you get whole numbers, and the whole numbers give rise to what we call the pH. Now, pH in itself stands for potential of hydrogen, but nobody would ask you this. Nobody will say, what is pH? If they tell you what is pH, don't write pH is potential of hydrogen. That is the full this is an acronym, so this is the full meaning of the acronym. But when they ask you to define pH, you are going to define pH as this. It's a pH, pH is a measurement that indicates how acidic or alkaline a substance is. Okay? So that is the definition. This is the definition. This one is just for your information because some learners are curious. They ask you, why is it called pH and not something else? So that's why I'm bringing this thing up. The pH means potential of hydrogen. But if they ask you to define pH, you say pH is a measurement of how acidic or alkaline a substance is. Now, to calculate pH, you use this formula. pH is the negative log of the hydrogen ion concentration. If you don't have hydrogen ion, like I indicated, the hydrogen ion in solution usually combines with water to form a dative covalent bond. This. So usually when we talk about concentration, when we talk about pH, we are talking in terms of the hydronium ion, this one, okay? Not just hydrogen. So either you quote it like this or like this, it's okay. Then we have what we call the pH scale. Now, the pH scale is a practical means of representing pH, and the scale starts from 0 to 14. So you'll see this in your lessons. Yeah, this is how the pH scale looks like. It starts from 0 to 14. Now, any value below 7 is acidic. So this whole region, if you calculate your pH and it's below 7, we say your substance is acidic. And if it's above 7, we say it is basic. It's basic or what we call alkaline. An alkaline is just a base that dissolves in water. So sometimes they use the word basic, sometimes they use the word alkaline. They are basically talking about the same thing. Now, as the strength of the acidity increases in this direction, it means that if you calculate your pH and you get 1, that pH, the acidity is stronger than a pH of 6. Okay, so 6 is weaker. However, when you're dealing with the basic part of it, that is the alkaline part of it, then the value increases with increasing uh, pH value. In other words, the level of alkalinity here, 14, it means it's very alkaline, but 8 is less alkaline, something like that. So basically, this is what we are going to talk about. And then you have this diagram there. Now, normally learners have a problem when you talk to them about pH. They think uh, pH is only as acids. If there's an acid, uh, okay, so let me paraphrase my statement. What I'm saying is that learners often think that if you say something is acidic, it means that it has only this hydronium. No, in every substance, because acidity and alkalinity are determined when substances are dissolved in water. So in every substance, you'd always have this plus OH, okay? Because water splits to give you something like this, H plus OH minus. This H plus, I told you, usually is in the form of H3, something like that. But let's leave it like this. So it means that in every substance, you would have this and this coming from the water. Then if it is, let's say, HCl that you have dissolved in water, the HCl also adds something to it, okay? So this is why we say water is neutral, because it has an equal amount of hydrogen ions and OH minus ions, equal amounts. Okay, so if they cancel each other, they are neutral. However, when you add something to it, a substance to it, like in the case of hydrochloric acid, the hydrogen from the hydrochloric acid increases the concentration of this hydrogen. And therefore, for every substance, you'd always have some hydrogen and some OH in it, whether it is acidic or basic. So when you have an acidic solution, the concentration of the hydronium ion, this one, is greater than the hydroxide ion. If it is a neutral substance, they are equal. Okay. And then if it's a basic substance, the hydronium ion is less than the hydroxide ion, something like that. So you should keep that in mind. Okay, so we are going to talk. Okay, this is just an example of a pH scale with different substances and how acidic or alkaline they are. You don't have to cram this. This is just something for your, own entertainment. Okay, so let's talk about an indicator. Now, if you want to find out whether something is acidic, basic, or neutral, we use what we call indicators. So an indicator is just a substance that changes color in the presence of an acid or a base. So you have various indicators here and the colors that their color in acid, their color in bases. You just have to find a way of learning them. But I'm not really going to waste my time on this because this you have to memorize. There's no shortcut to it. It's like learning someone's name. Okay, what I'm going to focus my attention on today is titration because that's where most of the questions come. And titration questions are actually an extension of the mole concept or amount of substance. So we are going to apply the same principles in titration, and most of them, learners don't usually score, well, they don't perform well. So let's look at what titration is. Titration is just an experimental technique that is used to determine the concentration of an acid or base using what we call a standard solution. Now, a standard solution is a solution whose concentration is known. So we are going to have a diagram like this so that you see what happens during the titration. So let's say you want to determine the concentration of a base, okay? So you put a given amount of the base using what we call a pipette. I think I'll have to search for a pipette, or you can just, it's called a pi pet with a double T. You can check it up on the internet. I don't have the picture here. So you take a given quantity of it. Let's say you put 25 centimeters cube of it here, 25 centimeters cube, okay? Then you use a dropper to withdraw an indicator, given amount of indicator, and you add a number of drops inside the base here. You put the drops inside here. Then you go and place it under this. This is called a burette. And then in the burette, you may have an acid here. So it has a tap. You allow the acid to drain into whilst you are shaking this one. This is called the conical flask. You shake it until there is a color change. When the color changes, we say neutralization has stopped. So based on the initial volume that you used and the final volume you use, you can know the amount of acid you use. And then based on that, you use it for calculations. So this is what we call a titration, acid-base titration. This is how it is carried out. I hope maybe in your school, if you have a laboratory, your teacher may decide to do it. So basically, this is another diagram to tell you how some of you might be wondering, how do you support this? Okay, how do you hold it upright? You usually support it with something we call a retort stand. It holds it like this whilst you basically do whatever you are doing there. Okay, so we are done with this topic. However, like I normally do, we need to do a number of calculations because the calculations will help you understand what is going on. Let me go back. Okay, so let's start with the first set of questions. The first one says that convert the following to concentration in mole per dm cube. So we talk about solution here. This is solution. We take A. This is 0.2 mole of sodium hydroxide in this. Now, concentration in mole per dm cube requires that this value should be changed to decimeter cube. Excuse me. Should be changed to decimeter cube. And 1 decimeter cube is equal to 1,000 centimeter cube. So you should remember that. Now, so this is how you go about this. You already know the number of moles here. Okay, the value is indicated here. So all you have to do is to use the formula concentration is equal to number of moles over volume. Your number of moles is 0.02 mole, and then your volume V is 80 centimeters. So we divide it by 1,000, and that gives us what? 0.08. Okay. Zero. So 1, 2, 3. Yeah. So you come here and say your concentration is equal to your number of moles, which is 0.02 divided by your volume, which is 0.08. Okay, so you take a calculator and then 0.02 divided by 0.08. And that gives you a concentration of 0.25 mole dm minus 3. Okay? So when you do that, you get the answer. Now, there's another way of doing it, and this is a technique that I would encourage you to also develop, because sometimes we call it proportion. It helps you answer questions quickly. Sometimes if you forget formulas or something, like I said, it's called proportion. And I think I may have taught you this at some point in time, but I want to repeat it. Let's say, let me use this illustration so that you see what I'm talking about before we apply it here. Um, let's say one man, one man has 4 legs. I mean, not 4 legs, 2 legs. Sorry. Let me clean this. Every man or every human being has 2 legs. Okay. So you say one man equivalent. These 3 lines stands for equivalent. Normally, when you say equal, equal is mathematics, but when you have two unlike terms like man and legs, you cannot say one man is equal to 2 legs because they are not legs, and man cannot be compared. Okay. So usually we use this, but even if you use equal, it's fine. If you don't want to use this equal, you can also use the arrow like this. So one man one man has 2 legs. So 10 men we know will have 20 legs. Okay, but how do we get this? We got this by, you can do it in 2 ways. You can cross multiply this. Let me erase this. So if one man has 2 legs, 10 men will have 20 legs. Okay, so let's put the answer here, 20 legs. But let's prove it. Let's call this X. We don't know. So what you do is that you can cross multiply this one, and this one. So one man times X. So 1X should be equal to 2 times 10. And that gives you 20 legs. Okay? So for this one to work, you have to put if this is man here, it should be man here. Legs should be legs. Don't confuse them by writing legs here and man here and legs here and man here, and then it becomes confusing. All the information here you have here must be equivalent to the one here. The one here must be equivalent to the one here. Then you simply cross multiply, and then you get your answer. Okay, so if you understand that, let's see whether we can apply the same principle with that. In this principle, this is what we are going to do. We are going to say that 0, 0.02 mole, I'm using this one, 0.02 mole is equivalent to this 80 centimeters cube. So 0.2 mole is equivalent to 80 centimeters cube, okay? Therefore, 1,000. Remember, 1 decimeter cube is 1,000 centimeters cube. What will it be equivalent to? We call it x. So you simply cross multiply. X times this, and then this times that. The value you get to be the concentration, because concentration is the number of moles in 1 decimeter cube. And 1 decimeter cube is 1,000 centimeter cube. I said the centimeter and the centimeter cube, they must be on the same side of this. So whatever you get is mole in that. So this one will be 80x should be equal to this one times this one will be 1,000 times 0, what? 0.2. Okay? So if you want to find the value of x is going to be 1,000 times 0.02 divided by what? 8. So this 1,000 will take this one, 2, 3. Okay? So 0.02 times 1,000, and that will give you 20 divided by what? 80. So divided by 80, and then your answer is 0.2. Let me put it here. 0.25 mole per dm cube. So this is the concentration. Let me go back here, and then you will see that we also got here 0.25 mole per dm cube. So if you want to go by the formula route, number of moles, volume, you change it, you get it. If you don't want it, you use proportion. But I think as a teacher, I haven't taught for many years. I think it's better you know the two skills, because there are times that this one will be more useful for you. Okay? So let's quickly go to the second. Oh, we haven't finished. There are more examples there. Let me go to the other examples there so that we don't. Let's go to the second example. The second example says 20 grams per dm cube. This dm cube is already in dm cube, so you don't have to change any volume, okay? You have to change, however, you have to change this one into number of moles, because concentration is number of moles over volume. This is mass, so this one has to be changed to number of moles. So we come to B, and then under B, we'll say number of moles is equal to mass over molar mass, okay? Or let me put it, yeah, let me erase it and write it well. The number of moles of sodium hydroxide is equal to the mass over molar mass, okay? The mass that was given was 20. The molar mass of sodium hydroxide, if you calculate, is going to be 23 times 1 plus 16, sorry, plus 16 times 1 plus 1 hydrogen plus 1. We know how to calculate it. Eventually, you are going to get 40 grams per mole. So you divide this by 40, and then you get 0.25. Okay? So 0.25 mole. Is it 0.25? No, it's not 0, it's 0.5. I don't know why I'm because I got 0.25 here. This is half of it. So it's actually 0.5. mole. So you come here. Because this is already in decimeter cube, okay? So the number of moles is also equivalent to the concentration. So your concentration is also 0.5 mole per decimeter cube, because it's decimeter cube, decimeter cube. There's no need to change that volume. It's already in decimeter cube. So the value you get is equivalent to that. Now, again, we are going to have something like this. This one too. 24 grams of sodium chloride per this. So we can change this one into number of moles quickly. So 24 into 300. So let me come here and then see what we are going to do. So this is C. This is C. So it's going to be 24 grams of sodium hydroxide in of water or solution. So what do you do? Sorry, it's not sodium hydroxide, it's sodium chloride. Sodium chloride. So again, number of moles of sodium chloride is equal to mass over molar mass. Okay? So to get the molar mass, the mass is already given. We are going to put it here. So the molar mass of sodium chloride is going to be 23 times 1. Atomic mass is 23. There are only one of them. And then chlorine is 35,5 times 1. Okay? So when you do this, you are going to get 23 plus 35,5. And that is going to give you 58,5. 58,5 gram per mole. So here you are going to have 24 over 58,5. And then 24 divided by 58,5. And that gives you 0,41, yeah, mole. But this mole is in this volume. So we have to change this volume to 1,000. So like I said, we can use proportion quickly. That's where I said proportion can be useful. You see, this 0,41 is contained in this. Therefore, 1,000 will be what? So you can say 0, you can say that 300 centimeters cube contains what? 0,41 mole. Therefore, 1,000 centimeters cube, because volume in terms of centimeters cubes is in dm cube, and 1 dm cube is 1,000 centimeters cube. So this is going to be equal to what? You call it x. So you can cross multiply this quickly and say that 300x is equal to 0,41 times 1,000. Okay, so your x is going to be 0,41. Oh, let me just multiply that. Times 1,000. This is going to be, excuse me, let me just multiply that quickly. We are going to have this, okay, divided by 300. Yeah, let me see whether I'm doing the right thing so that I don't make a mistake. Okay, so this divided by 300, and your answer would be 136 or 137. We can make it 137 mole per decimeter cube. Okay, if you want to go through the formula route or route, you can also do that after you get here. Okay, when you get the number of moles, I mean the number of moles here, So this will be the number of moles, this will be the volume, but this volume has to be changed to decimeter cube. So you are going to, you can also use the formula concentration is equal to number of moles over volume. The number of moles according to this one is 0.41, 0.41. The volume is 300 over 1,000 because we are converting it into decimeter cube. So you're going to have 1, 2, 3. So you're going to have 0.3, 0.3. Okay. So let's see whether we are going to get the same thing. 0.41 divided by 0.3. And yes, we have 1,366, which is the same thing as 1,37 mole per dm cube. So whichever way you do it, you will get the same thing, okay? Whichever way you choose, but the proportion, keep it at the back of your mind. It will be very useful, especially when you are going to, if you decide to pursue the sciences in future. Okay, so now let's look at a real titration question. This one was just an introduction. Let's see how we apply the principles of what we have learned so far in real questions. Okay, so let's look at it. They say consider the following reaction. Hydrochloric acid reacting with sodium carbonate will give you sodium chloride plus water plus carbon dioxide. It says that in a titration, 20 centimeters cube of 0.1 mole per dm cube sodium carbonate were neutralized by 30 centimeters cube of dilute acid. Calculate the concentration of the acid. So this is a titration. And to answer this question, I'm going to draw your attention to something. You would recall somewhere when I was teaching you the mole concept, I said something like, if you have a reaction, let's say A plus B, sorry, to give you C plus D. Let's say the coefficients here are A, B, C, and D. Then the number of moles of, the number of moles of A divided by the coefficient must be equal to the number of moles of B divided by the coefficient must be equal to the number of moles of C divided by the coefficient and must also be equal to the number of moles of D divided by the coefficient D. And I said you can turn it upside down. We did that. And I remember I told you something to the effect that when a chemical equation is balanced, it's like there is a chain that links them, a chain. Okay, this is called a chain, like one chain, another chain. I mean, these are rings that are chained together. So if you know this, you can follow your way through until you get here. Even if you are blind and you hold one end of this, without looking, you can move your hand like that up to the end. So a balanced equation has this link and you can use it to calculate anything. If you know information about one, you can use it to determine the information of the other. I remember I also gave this illustration that if you're a cop and then you go around, maybe on your night duty, you are the only one, and you see a number of thieves breaking into someone's shop. If there are 10 of them, don't worry yourself to catch all 10 of them because you are just an individual. Because they came in a group, just try your best to catch one. And once that one is arrested, he will lead you to the others. He will reveal the identities of the others. So when a chemical equation is balanced, there's always a link. If you know information about one, that information can help you calculate or determine the information of the others. So having said this, now let's come and answer this question applying this concept that I have just explained. Okay. So when you are giving something like this, it's always good to write the information because the things are so many. Okay. So I would say something like this. This is our acid. So this is acid and this is our base. Okay. So you can say the concentration of the acid or ACl, you look there, it is not given, it's unknown. Okay. The volume of the acid were neutralized by this of dilute acid. So this is 30 centimeters cube. Then the concentration of the base, that is your sodium carbonate, was 0.1, 0.1 mole. And then the volume of the base is 20 centimeters cube. So this is the unknown factor. This is what you are supposed to find. It says calculate the concentration of the acid. This is the unknown factor, but you have this. Now, we are going to apply the principle that I just indicated, and I'm going to include something new so that you see what I'm talking about. I think I'll just use it directly here, and then you'll see. Now, recall that I said concentration is equal to number of moles over volume. So your number of moles is CV. Okay, CV, curriculum vitae, CV, like this. So number of moles is always equal to CV. Now, if you look at this, what I illustrated earlier on, we can say something to this effect, that in place of the number of moles, we put CV. Okay, remember, okay, so for this one, I think I should do it like that. I can use that chain that I showed you. I can say number of moles of hydrochloric acid divided by 1, because the coefficient here is 1, divided by 1 must be equal to the number of moles of what? Sodium carbonate, this one, also divided by 1, because the coefficient is 1, divided by 1. That's what I indicated with that chain. Okay? Okay. So, but then we also know that number of moles is equal to concentration times volume. So here we can write, in place of this number of moles, we can say concentration of the acid. This is an acid. Concentration of the acid times the volume of the acid over 1 must be equal to the concentration of the base times the volume of the base over 1. Now, anything divided by 1 is that thing. Okay? So we are saying that the concentration of the acid times the volume of the acid should be equal to the concentration of the base times the volume of the base. Okay? So this is what you are going to do. Then you substitute the information, or we can even make the concentration of the acid as, because that is what we are looking for here. This is the unknown. In this question, the concentration of the acid is the unknown. That is what we are supposed to find. So we can make it the subject of this equation by dividing both sides by the volume of the acid and divide this by the volume of the acid. So this one cancels this. Then we'll say concentration of acid is equals to concentration of base times volume of base over the volume of the acid. Volume of the acid, okay? So we just substitute it here. Now with this one, there is no need to convert it to decimeter cube. The reason being that they are both centimeters cube and they are, okay, so let me just illustrate it so that you see what I'm talking about. The concentration of the base is 0.1. Okay? So we are going to put here 0.1 times the volume of the base is 20. Let me put centimeter cube so that you see what I'm talking about. Divided by the volume of the base is also what? 30 centimeter cube. So the centimeter cube and the centimeter cube will cancel each other. So for this type of question, there's no need to convert it to decimeter cube. It will be a waste of time because they will cancel each other. So this one here is going to give you 2 divided by 30. And that gives you 0.067 mole per decimeter cube. So this is how you answer this one. Okay? This is how you answer this one. Now let's move to the next one, and then we see how we go about this. This one also says, in a titration experiment, 21.6 centimeters cube of sulfuric acid was required to completely react with 25 centimeter cube of sodium hydroxide containing 2 grams of alkali in, alkali is the sodium hydroxide. I told you alkali is a soluble base. So 2 grams of the alkali in 500 centimeters cube of solution. Then this one says, write down a balanced equation for the reaction. Okay. So for A, we're going to write the reaction was between the acid and the base. The acid is sulfuric acid. So you're going to have H2SO4 plus sodium hydroxide. This is a neutralization reaction. When I started, I told you that when acids react with bases, you form salt and water. Okay? So the salt is going to be sodium sulfate plus water. Okay? And then because this is 2, you put 2 here. And then your water also becomes 2. So it is balanced. This is the balanced equation. This is the balanced equation. That is A. Now we'll come to B. Calculate the concentration of sodium hydroxide in mole per dm cube. So we come here. Now, the sodium hydroxide, okay. So you leave this one here. I know this can be a bit confusing. You leave this here and say sodium hydroxide containing this gram of alkali in this, because there are so many volumes, sometimes you can get confused. Now, this is 2 grams. It is in 500 centimeters cube. Now, to convert it, to make sure that we are dealing with the same quantities, we have to convert this to 1,000. How much will be in 1,000? That will be 2 times 2, because 500 centimeters cube times 2 gives you 1,000 centimeter cube. So if 2 grams are in 500 centimeters cube, then 4 grams will be in 1,000 centimeters cube. So we are going to say that we are going to have 4 grams per decimeter cube. Okay? But then the question is says we should find the amount in mole per dm cube. Now there is a we have to convert this one. We have to convert this one into moles and then it to be dm cube. So we know number of moles is equal to number of moles of sodium hydroxide is equal to mass over molar mass. We have already calculated the molar mass of sodium hydroxide as 40 previously. So there's no need to, if you look here, there was one, yeah, this one. There was a certain sodium hydroxide B. Yeah, the molar mass of sodium hydroxide, we calculated it as 40. Of course, you always have to calculate it, but I mean, for purposes of this, we know how to calculate, so there's no need to show you that. So this one is 40, and then your mass is 4, okay? So your 4 into 40, 4 divided by 40 gives you what? 0.1. So the concentration is 0.1 mole per dm cube, okay? So that is the second question, B. Then the third question is C. The third question says that calculate the concentration of the sulfuric acid. Now we know the concentration of the base. So we are going to use our formula, the previous formulas that we used to answer this. We are going to look for our information. Concentration of the base is equal to 0.1 mole per dm cube. Then that's what we calculated in the previous question. The volume that was used was 25 centimeters cube. So the volume you put it as, where is the volume? Let me push this one backwards. So the volume of the base, is 25 centimeters cube. Then concentration of the acid is what? We go here. The concentration of the acid. Oh, there's something missing here. Why did I miss it? Just give me a minute. Let me see where I took the question from. Just a short period. If I don't see it, then we can just move on. I copied it from somewhere, though. We need the concentration of the acid, not just the volume. Let me see something. Oh, one thing. No, that's what we are supposed to find. There is nothing wrong with that. Let me see. So the concentration of the acid, we don't know. That is what we are supposed to find. Then the volume of the acid is this. So the question is correct. The volume of the acid is this. Okay. Is 21,6. So this is 21,6 in this. So that is what we are supposed to find. So now let's see how we deal with this. Now this question is a bit tricky. I chose to include it here. Remember I said, if we were dealing with, it's like I've taken a lot of space. Let me copy this equation again, Let me copy it down here so that you see what I'm talking about. This is sulfuric acid plus sodium hydroxide would give you sodium sulfate plus water. The water, there is 2 here and there is 2 here. So remember I said, for this reaction, if we're not dealing with concentration, let's forget about concentration for a while. If we're not dealing with concentration, we would have said the number of moles of H2SO4 divided by its coefficient, which is 1. The number here is the coefficient 1, must be equal to the number of moles of what? Sodium hydroxide divided by its coefficient here, which is 2. Okay? Okay. So, if you want to do it, we know previously that number of moles is equal to concentration times volume. So here we'll say, instead of putting the number of moles here, we'll say and this is an acid. So we say the concentration of the acid times the volume of the acid divided by 1 must be equal to the concentration of the base times the volume of the base divided by 2. Do you understand? Okay. Now, if we want to find, now this one, anything divided by 1 is that thing. So we don't really have to divide by 1. We can just continue it like this. But for purposes of this, let me also show you another way of doing it. And then I'll go back to, let me rearrange this. We can rearrange this so that you see something. Before we rearrange it, let me just give you a certain hint. I usually like repeating these things because learners often forget. Let me show you something. Now, in one of the lessons, I don't know whether it's your grade or the previous grade, grade 10s, I indicated that we all know that 5/10 is the same thing as half. Okay, so 5 divided by 10 is the same thing as half. So if you cross multiply this, you are going to have uh, 10 times 1. 10 times 1 is equal to 2 times 5. And 10 times 1 is 10, 2 times 5 is also 10. So usually when you have something like this, we cross multiply, okay? We cross multiply because that is what is going to give us. Now look at this thing. I could have chosen to change this in a way. Just look at what I'm going to do. Uh, so this 5 over 10 is equals to 1 over 2. I can put this 2 on top here and bring this one here, and they will be the same. Okay, let's see whether it makes sense, but let's see. I haven't tried it, but let's say 2 over 10. I've taken this 2 because it's cross multiply. 2 times 5 is the same thing as 5 times 2. So this 2, I can put it here. I can take it and put it here at the numerator and bring the 5 down here. So 2 divided by 10 must be the same thing as what? 1 over 5. And that is true because 2 into itself is 1, 2 into that is 5. This is 1 over 5, 1 over 5. Okay, so if you see the logic in this, it means that even these ones, the whole of this, because we want to arrange them such that they will be together, the whole of this information can be brought down here, and this one can go up here. So there we can say CAVA over CBVB must be equal to, this one goes up here, 1 over 2. So now we are dealing with, you see the CV and the CV are on the same side, and the numbers are on the same side, okay? So this is how we rearrange it. So going forward, this is what we are going to do. Going forward, anytime they give you an equation, like, let me write the equation again. Let me write the equation again before we solve this question so that you see what I'm talking about. So the equation was sulfuric acid plus sodium hydroxide would give you sodium sulfate plus water. The balanced equation is like this. So going forward, instead of using that period, we are going to use this. You can say concentration of acid, volume of acid over concentration of base, volume of base must be equal to, if this is acid, the coefficient here is what you write here. So this is 1. We put it here. So this, if it's acid, the numerator is for acids. So the coefficient here must be for acids. Then concentration of base times volume of base will be 2 because this is the base. The coefficient here is 2. If you don't want, it doesn't always have to be acid divided by base. Even base divided by acid will still give you the same thing. Let's look at this. We can say that concentration of base, volume of base divided by concentration of acid, volume of acid must be equal to, so if this is base, whatever is in front of the base, you put it there, 2. So the 2 becomes the numerator, and the denominator is for the acid is 1. You can see that it's the same thing. If you are going to multiply this by, you see, this by this, and then this by that, is the same thing. 2 times CVA. Also, this 2 times CVA, and then 1 times CVB. Okay, so just have this in mind that going forward, we can always write it like this instead of going through this whole process of number of moles and change. We can just say CAVA divided by CVBV, then you take the coefficient there in front of it, of the numerator, to correspond with the acid. If the acid is the numerator, and the denominator, we write it like that. Okay, so now let's come back to what we got here. Let me clean this thing so that I don't have to be copying and recopying. So let me just go here. So based on this one, uh, based on this one, yeah, okay. So based on this one, we can say that the concentration of the acid times the volume of the acid divided by the concentration of the base times the volume of the base must be equal to, if you're using the acid is the numerator, so the coefficient here must be 1. The base is the denominator, so we use the coefficient here 2. So here we are going to substitute and say that the concentration of the acid we don't know. So the concentration of the acid we don't know, but the volume of the acid we got it as what? 21,6. So 21,6 Ca, okay, divided by the concentration of the base. The base is 0,1. This is the concentration of the base is 0,1. So the concentration of the base here, we put 0,1 times its volume. The volume here is the volume here is 25 centimeters cube. Okay. So times 25 must be equal to 1/2. So the rest is mathematics. You cross multiply again. Take this one here and this one here. So we're going to have 2 times 21,6 Ca, okay, must be equal to 0,1 times 25 times 1. We don't include it times 1 if you want to put it times 1, but it doesn't make sense. Okay, so our concentration of the acid is going to be, we divide the whole thing. We divide here by that and divide that by that. Concentration of the acid is going to be 0,1 times 0,25 divided by 2 times 2,16. Of course, you can do this and solve it, without having to get this far. You can find the answers much earlier. So 0.1 times 0,25 equals to, so the numerator is 0,025. And then the denominator is this one, 2 times 21,6. And that gives you 43,2. Okay, that gives you 43,2. So we are going to divide that. You're going to have 0,025 divided by 43,2. And the answer is, calculated, is 5,7 times 10 raised to the power minus 4 mole per dm cube. So that is how we go about answering this question. Yeah, that's how we go about answering this question. Okay, so let's see. I don't want to waste my time. It's already almost an hour. I don't want to waste my time answering this one. I want us to deal with real past questions. These are all my creations just to prepare you for the real past questions. So let's go to the previous questions and see what we are dealing with. This is one of the past papers. It says a bottle in the laboratory contains an unknown metal, and the formula of the metal is MOH. A lab technician dissolves this amount of the metal to make 100 centimeters cube of solution. Upon analysis, it was found that the concentration of the metal oxide is this. Define the term, define the term concentration. So you say concentration is the number of moles dissolved in 1 dm cube of solution. So you say concentration, okay, so this is 6,3,1. You say concentration is number of moles of a solute dissolved in 1 decimeter cube of solution. That is concentration, the definition of concentration. The number of, there is a difference between concentrated and concentration. Concentration is number of moles over volume. That is the formula. But to define it, you say concentration is the number of moles of a solute dissolved in 1 decimeter cube of solution. So we have finished with the first one. Then it says, determine by calculation the name of the metal oxide. And you can see it's 5 marks there. Now, 5 marks means that there has to be some calculation. You can't just, come up with something. Now, this is how we go about it. You see, this one is in decimeter cube. This one is in centimeter cube. So a better way is to find out how much is in 1,000 centimeters cube. Okay? So if this gram is in 100 centimeters cube, what will be in 1,000? That's why I said proportion is very important. So it's times 10, but I'll just show you through proportion. You say 1,86, no, 1,826, not 86, 1,826, 1,826, we are dealing with 6,3,2. 1,826 grams is equivalent to 100 centimeters cube. So what would be the amount in 1,000 centimeters cube? We give you X, okay? So you cross multiply here. You're going to have 100X is equal to what? 1,826 times 1,000, okay, divided by, times 1,000. There's no divided by. But if we want to find X, we say divided by 100 and divided by 100, okay? So this one will take out this 2. Okay, so eventually I'm just going to have 10 times this one because this cancels that. So this one takes away 2 of this 0, and then you'll be left with 10. 10 times this gives you the value of X. The value of X is 18,26 grams. Okay, so let's put it aside. Now, when you're given any question for that matter where you are supposed to determine the formula of something, you should be able to calculate the number of moles, and then from the number of moles, you determine the molar mass, and from the molar mass, you determine the formula. Any question that sometimes they can give you an acid is given by AH, and then they'll give you something. Find what A is or X is, and then therefore determine the value of this. Anytime you are giving this, try to see whether you can find the molar mass. And then from the molar mass, you determine what M is. So let's see what we are going to do. We have been able to determine the mass in 1,000. And then we know the moles in 1,000. This concentration is number of moles in 1,000. So it's actually number of moles, but then the number of moles in 1,000. Then we've also found the mass in 1,000 centimeters cube, okay, or 1 decimeter cube. So this is actually the mass, and this is the molar mass. So what you're going to do is you will say something like the number of moles of MOH is equal to the mass over the molar mass, okay? So we have the number of moles as this 0.326, because that's the number of moles in a DM cube, 0.326. So you say 0.326 should be equal to the mass. The mass here is 18.26 divided by the molar mass. So if we want the molar mass, the molar mass is equal to, we take this one here and bring it, this is like over 1, like the cross multiplication we have been doing. All you have to do is to take this one and put it here, and take this one and bring it up here. So it's going to be something like this. You're going to have 18.26 divided by 0.326. So we divide that, and what do we get? 18.26 divided by 0.326. And that gives us 56. So the molar mass gives us 56, according to my calculations, 56.1 gram per mole. Okay, so that is the molar mass. Now, we are not interested in the molar mass alone. We have been asked to calculate, to determine, because it says, what is the name? Let me go back to the question. It said, determine by calculation the name of the metal hydroxide name. So to know the name, we should know what M is. So we are going to put it like this. We are going to say 56.01 is equal to, you know how we calculate molar mass. Let me do it again in a way that if we're calculating molar mass, we say molar mass of MOH is going to be equal to M times 1 plus oxygen times 1 plus hydrogen times 1. Okay, so this one is our 56.01. The M times 1 is M, plus oxygen is 16 times 1 is 16, plus hydrogen is 1 times 1 is 1. Okay, so here you are going to have, let me move this one backwards. So here you are going to have something like this. This is equal to our M plus 17. So M is equal to 56.01 minus 17. I think we can even get rid of the 01 and just say 56 minus 17. And that gives us what? 39. So M is equal to the molar mass of, the atomic mass of M is 39. And if you go to the periodic table, the substance or the element with the element with the mass, the relative mass being 39 is potassium. Check the periodic table. K is potassium. I think it's written like this. K, 39, and then this is 19. It's potassium. So this is called O. Actually, the substance should be KOH, and the name is potassium hydroxide. So this is how you calculate it. Do your calculation. Okay, so let's see whether we can try. Let me see how many more questions do I have. Okay, let's continue with this one and see whether we can also add another one. Okay, so this is another past question. It says that in a titration, the learner finds that 20 centimeters cube, okay? The learner finds that 20 centimeter cube of this solution of sodium hydrogen carbonate neutralizes 12 centimeters cube of the sulfuric acid. The balanced equation is this. Why is sulfuric acid regarded as a strong acid? You say it completely dissociates in aqueous solution. Okay, to give a high concentration of H plus ions. The definition is there. So strong acid, strong base. You just go and find the definition. Then, how many moles of this are present in this of sodium carbonate? So you come here and look. Let me go to 7.2.1. We have answered that. So 7.2.2. How many moles of that? You are given the volume of the sodium hydrogen carbonate as 20 centimeters cube. So we say the sodium hydrogen carbonate in this case is the base. So we say the volume of the base is, or if you don't want to get confused, sometimes learners don't know which is base, which is acid. You can just say volume of sodium hydrogen carbonate. Sodium hydrogen carbonate here is 20 centimeters cube. Okay, say 20 centimeters cube. And then the concentration of the sodium hydrogen carbonate is given to you as what? The concentration here is 0.2 mole per dm cube. So this is 0.2 mole per dm cube. So the question says, how many moles? So it's a number of moles of sodium hydrogen carbonate is equal to, no, not number of moles. Okay, number of moles is equal to concentration times volume, CV. I wanted to say C is equal to N over V, and therefore N is equal to CV, but we have done it previously, so you should know how I got this. Okay. So the number of moles here is going to be, the concentration here is 0.2. Okay. The volume is 20, but it's in centimeter cube, so we must divide it by 1,000. You can divide the whole thing by 1,000. And then your answer will be 0.2 times 20 divided by 1,000. And this one is going to be 0.0004. 1, 2, 3, 4. Okay. Mole. That's the number of moles. 3 zeros before the 4. That is the number of moles in 20 centimeters cube. So that is the second one. The second question that we have answered. Okay. Then we move to the third question. Determine the number of moles of sulfuric acid that are neutralized by this volume of that. Okay. Determine the number of moles of that. Okay. So with this one, we can't use that C over what. We go back to the previous kind of calculations that we did, or the previous way of doing the other one. That's why it's always good to be able to switch. You know, it's like switching between apps. So sometimes you have to use this, sometimes you have to use that. Let me copy this one down so that I want to copy this one there so that, you know, we know what we are doing. So, by the way, let me see something. This is one, sodium hydrogen carbonate sulfuric acid, okay? So, 2 sodium hydrogen carbonate plus sulfuric acid should give us sodium chloride plus water plus carbon dioxide. This is 2, this is 2. Yeah. I mean sodium, not sodium chloride, sodium sulfate. Sorry. Sodium sulfate. I'm not really interested in this side. I'm interested in this one and this one. So because we have calculated the number of moles of this one here, this is for this one. We want to find the value for that. Okay? So we go by our old method, what we are used to. We can say that the number of moles of sodium hydrogen carbonate divided by its coefficient, this coefficient is 2, must be equal to the number of moles of sulfuric acid. Yeah, the number of moles of sulfuric acid, the number of moles of sulfuric acid all over 1, because the coefficient here is 1. This is what we did previously. This one, we are not using CAV's VA over, you don't use that one here because they have already asked you to calculate the number of moles. So it will be going backwards. So we use this principle. Now, this number of moles of, it says calculate the number of moles, determine the number of moles of sulfuric acid. So this is what we are supposed to determine. So anything divided by 1 is that thing. So we can simply say that the number of moles of sulfuric acid, this is H2SO4, must be equal to half of this, the number of moles of sodium hydrogen carbonate divided by 2. Okay? Because of this, I got this one from this one. Is what I put here. I just flipped them, started with this one first, like making it the subject or putting it in front so that you know what I'm talking about. So the number of moles of sodium hydrogen carbonate in this question was this one. So we are going to say that this is 0,0004 divided by 2. That is 0,0002 mole. So that is what we get for this question, 7.2. Then 7.2.3 is the answer we got there. So 7.2.4 says calculate the concentration of this one. So this is the number of moles. So we simply say concentration is equal to number of moles over volume. The number of moles here is 0,0002. The volume of the acid, if we go back here, we will see that, oh, we didn't put the volume there, but if you go here, you will see that the volume of the acid was 12. Neutralizes 12 centimeters cube. So 12 is 12 centimeters cube is the volume of the acid, but we have to divide it by 1,000 before we can substitute it here. So we say the volume of the acid is 12 divided by 1,000. Okay. And we'll give a 0,0. This is 0,012. So we divide them 0,002. There are 3 zeros. 2 divided by 0,012. And that gives us 0,0167 mole decimeter cube. So this is how you calculate it. Okay. Let me just answer this one, and then that would be it. We'll call it a day. Let's see how we answer this one. Okay. Now, this one says that a standard solution of carbonate, a standard sodium carbonate solution is prepared in this volume of a volumetric flask. We'll come back to that. Now, it says that during a titration, this centimeters cube of this nitric acid neutralizes 25 centimeters cube of the above solution according to the following reaction. Write down the name of the salt form, calculate the mass of the carbonate used to prepare that. Okay, so the name of the salt formed is this one. This is the salt, this is water, this is carbon dioxide. So this is called sodium nitrate. Okay, sodium nitrate. So that is that one. This one is the one that we have to take our time to deal with. So because we know something about, so it's calculate the mass of the carbonate that was used. The carbonate is this one. Okay, before we calculate the mass, we should know the number of moles. So it's quite a long and tricky question, but we still can answer it. Now, we have this one. So let me write here 9.3.2, okay? This 25 centimeters cube nitric acid is a nitric acid. So that is the acid. So we say, and this one is the concentration of the acid. The concentration of the acid is 0.1. The volume of the acid is 20 centimeters cube. Then the concentration of the base, we don't know it. The volume of the base in this case was this. This one would come later. This 250 would come later, but for the titration, this is what was used. So this one, you say 25 centimeters cube. So what do? You go to this. We need to find the concentration. Then from the concentration, we'll go to the mass. So you say concentration of acid over volume of acid divided by the concentration of base, volume of base, should be equal to the ratio. The ratio of the acid, the coefficient here is 2. So you put 2 over the base, the coefficient here is 1. Okay? So what you are going to write here is the concentration of the acid in this case is 0.1 times the volume of the acid here is 20 over the concentration of the base we don't know times the volume of the base is 25. Sorry, it's 25 centimeters cube. Should be equal to 2 over 1. Okay, so we cross multiply there and say that, so one times this is the same thing. So I just put 0.1 times 20, okay? Because 1 times that is the same thing. Must be equal to C, concentration of the base, times the volume of the base times 2, okay? Because of this 2, we are multiplying that. And therefore, the concentration of the base, we can divide this by 50. This is 50. We can divide this by 25 times 2 so that these 2 will cancel. We divide this by 25 times 2. So this is going to be 0.1 times 20 divided by 50. Okay? So this is effectively, because it's 0.1, we can just make this one 2 over 50 because of this. If you multiply it, you'll get 2. So 2 divided by 50 is equal to what? So the concentration of the base is 0.04 mole per decimeter cube. Okay? Okay. But the question is asking us for mass. What mass? Calculate the mass of the base. Okay? Now, To calculate the mass of the base, we know that the value that we got here. Let me see. What is the concentration of the base? Excuse me, during the titration, calculate them. Oh, okay, in the full volumetric flask. Okay. So, yeah, it's a bit confusing. Sometimes you have to think, or else you'll be found wanting. Okay, so I've gotten the clue. So this value here, this value here, look very carefully. This value here, the concentration of the base. The concentration of the base here is 0.04 mole per dm cube. It's the same thing as 0.04 mole per 1,000 centimeters cube, because 1 dm cube is 1,000 centimeters cube. So we can use proportion. We can use proportion to do this. So what you're going to say is that 1,000 centimeters cube here is equivalent to 0.04 mole. Therefore, how much will be in 250? This 250, how much would that be? So you say 250 centimeters cube would give you what? This is called proportion. So like we said, we cross multiply here. This is x. So we're going to have x times 1,000. So we say 1,000 x must be equal to 250 times 0.04. Okay? So our x is going to be 250 times 0.04 divided by 1,000. Remember, we divide it by 1,000, we divide it by 1,000. Okay? So this is going to be 250 times 0.04. The answer is 10 divided by 1,000. And then we're going to get 0.01. So this 0.01, by the way, is mole. Remember, this is centimeter cube, mole, mole. So this is mole. But they are not interested in mole, they are interested in mass. What mass? Okay, they're interested in this mass. So we have to calculate in terms of this. Remember that, let me just, come in, let me send a message and understand. Okay, so what do we do? Now we need to, yeah. So what we are going to do is, this is the last question. We are going to, okay, say that number of moles of sodium hydrogen carbonate should be equal to the mass over the molar mass, okay? So we make mass the subject, because the question says what mass? So mass becomes the subject, and therefore our number of moles, our mass becomes number of moles times molar mass, okay? The number of moles, we have already calculated it here. So what we need is to calculate the molar mass of sodium hydrogen carbonate. So you see the molar mass of sodium hydrogen carbonate is equal to 23 times 1 plus 1 times 1 for hydrogen plus 12 times 1 plus 16 times 3. Okay, so this one gives you 23 plus 1 plus 12, and then 16 times 3, I think it's 48. Eh? 16 times 3, as if it's something. No, no. Yeah, 48. So plus 48. So it's going to be 48 plus 12 plus 1 plus 23. And that gives us 84. Okay, so this is 84 gram per mole. So this one here is what we put here. And then the number of moles, we calculated it earlier, is this one. So we say that the mass is going to be 84 times 0, 0, 0, 0, 0,01. Yeah, 0,01. So 1, 2, 2. So this is 0,84 grams. So basically, that is the end of this topic. Thank you. I'm done. I'm done. You can switch off. I'm done.